All right, we're going to take a moment here and break this thing down a little bit because this equation and knowing what this equation means is oh so important. So I'm going to really take some time here to try to lay it out. First of all, I got a y here, I got an x here. I think it's a heck of a lot easier to actually write out what the y and what the x mean. So that's, time to boil is equal to 221.6 times, I'll use a little x there, how many liters of water you started with, and then we add on this number right here. This is a prediction. I mean, it's a prediction equation in the sense that tell me how many liters of water you got, and I'll tell you how long it's going to take to boil. At least based on the data we've collected, this is our best prediction based on that nice graph that we produce. Now, this is a linear equation, and you might remember that linear equations have the general form y equals mx plus b. There's our m, there's our b. All right? What does that mean, right? I mean, this is just stuff we remember from math class. You could probably recite some of this stuff to me if you really dug it out of your memory. Supposedly you all learned this. Here's slope, and this is called the y-intercept. And maybe some of you remember the definitions of some of this stuff, but what I'm really aiming for is something much deeper. I mean, you could, again, look at this and say, yeah, I remember y equals mx plus b. What does that mean, right? What in physical terms, in real terms, given our actual set of data that we've got, what the heck is the meaning of all this stuff? Well, let's try to actually establish that here. Here was our graph. This number, 221.6, supposedly is our slope. Slope to me gives me a picture of my head of steepness. I could draw a line with greater slope if I had something like, drew this line. That's pretty steep. Something that's less steep would be closer to horizontal. Heck, I could have a negative slope if my line was slanting down like this. So that is what we think of when we think of slope. Y-intercept, in physical terms, that's where it intercepts the y-axis. That's why we call it the y-intercept. The y-axis is this axis over here, and so it intercepts the axis at apparently 49.2, which is right around where I just drew that dot. That still doesn't really tell me a whole lot about what these numbers truly deeply mean, though, because these numbers, everything we're looking at here, we're actually dealing with physical stuff. Some quantity of water and some time it took for me to boil that water. So what do these numbers actually tell me? They're not just stupid numbers that exist to torment us. No, they have meanings. They have meanings. This number here, for instance, has a very important meaning. All right, I'm going to interpret this for us. And the way I'm going to do that is take a look at what would this equation tell me it would take in terms of time to boil 1 liter versus 2 liters. I've calculated out the 1 liter case here, and this, I don't have to do it again. We did this just moments ago for 2 liters. Then I want you to take a look at the difference between these two values. By how much do those two values differ? They differ by this. That's the value of our slope. So what does the slope value actually mean? It means this. Every time you bump up the amount of water you got by 1 liter, for every extra liter you put in there, it's going to take 221.6 seconds longer to boil. This is related to the notion of slope being, some of you might remember, rise over run, other sorts of things. This is a much more I would say, conceptual way of thinking about what that actually means for us. In general, you could say it as follows. Every time I increase my x, whatever the heck x is, if I increase it by 1, y goes up by whatever my slope is, 221.6 in this case. Now here's what's kind of cool. This thinking, what we've just outlined right here, is very, very much like what we were doing earlier. I'm going to have us recall how we were thinking through this situation before. We had thought through in strategy number 2. We were thinking about this in terms of, okay, every time we add a quarter liter of water, it's going to take this much longer to boil. The only difference between what we were doing before and what we're doing now is that the increment is now bigger. We're thinking about in terms of adding 1 liter instead of a quarter liter. But these things are like, they're very tightly tied to one another. Let's go back to what we did here. If I predict that it'll take an extra 57.75 seconds to do an extra quarter liter of water, using our method before, how much longer would it take to boil a whole liter of water? 4 of these increments, 57.75 for every extra quarter liter. This was predicting if I added in a whole liter, 1 liter, it would take me an extra 231 seconds. The number here is slightly different because we went by a little bit of a different method. Excel, used this line of best fit to get this number, but it's the same idea. It's just telling me that it's going to take me an extra 221.6 seconds longer to boil it. All right, that's the slope. We just interpreted this thing right here. We've interpreted what the heck the slope means. Now let's take a look at that y-intercept thing. I showed you on the graph what y-intercept kind of means, but again, it has a physical interpretation here, and it's worth noting what it is. In general, when we say y-intercept, we're talking about this in terms of if x equals 0, what's y? And why does that make sense? Take a look at your equation up there. If x equals 0, 221.6 times 0, well, that's just 0. And then I guess y equals 49.2. It's whatever left over. If x equals 0, y equals whatever the y-intercept is. That's what it all is about. That's why I wrote it like this. So according to my equation, for 0 liters of water, we predict that it would take, wait a second, that's a little funky, right? What does it mean? Like, first of all, don't put 0 liters of water in your tea kettle. It will not be happy. You probably would cause damage to it. This is a little hard to interpret here because for us, for our situation, you can't boil water if there isn't any water in it. That doesn't really make any sense. So in this particular case, maybe let's not worry too much about what this actually means because it's not really a physically relevant thing. But that's not always the case. Sometimes this y-intercept has a very important physical meaning, and we have to interpret and think about what that actually means and what the number ought to be. In this case, I don't know. Let's not worry too much about it, but in general, the interpretation is exactly this. What does it mean? It tells you the y-intercept, that value, 49.2, tells you what y is going to be when x is 0.